either it's going to be data listed like this. The mean age of 5 people. The mean age of 5 people in a class are. Then they show you. So when you meet the word mean, either it could be like this. The mean age of 5 people in a class are 5, 5, 7, 7, 7. For example. Or 5, 5, 6, 7, 7, 7. The mean of 6 students. These are the 6 students in a class. Here are their ages. You have 6 students in a class. Here you have their ages here. Then they say find the mean age. So there are 3 formulas for mean. Number 1 is you say mean is going to be equal to, you add the things. So you say sum of x divided by the number of things. This is the first formula for mean. Then the second formula for mean is going to be equal to the summation of fx divided by the total frequency. This is the second one. Then the third one is, so this is the summation of x over n. Then the summation of fx over the summation of f, which is the total frequency, which is the total number of things. The third one is mean. Remember, the other word for mean is average, okay? The third one is mean. Okay? It's actually the same way, but it's just 3 formulas. We change a little bit. You use this one when you have ungrouped data. Then you use, so I want you to get 100. Everybody, you get 100 on mean, please. You use this one when you have grouped data. It will be grouped data. In other words, it will be in a table. Grouped data is in a table. But it will be discrete. I'll show you what it's like. Then this one is the most popular. Okay, I'm gonna repeat. Okay, I'm gonna repeat. This one is the third and final way to find mean. Mean question is coming. You gotta get 100 on it. We're gonna move through everything, and we'll be just doing all the big things. So don't worry, we'll do all of them. This is for grouped data, and it will be continuous. This is the most popular one, which comes a lot of times. But still, I've seen papers where this one comes, and I've seen papers where this one comes. So let me explain. Quick, fast. What makes us have 3 different formulas for mean is that we have 3 different types of data. This one, where they give you like this, the moment you see data being listed, they list the data like this. This is called ungrouped data. It's not in a table, so it's ungrouped. If you have ungrouped data like this, you use this one for mean. What is mean? You add all the things, then you divide by how many they are. So let's say I get this one and they say mean. Once I see the word mean and I see this type of data, I'm going to right away put this formula. Mean is going to be equal to the summation of x over n, right? This is the formula I'm going to put right away. Like the moment I see this, this is going to be the formula I put right away, class. So look at what you do. Look at what you do as a class. What you do is, you would say, let's add all the things. Let's add all the things, class. We have 2 5s. So you say 2 by 5, 2 or 5s. Plus, let's add, we have only 1 6, so you say 6. Plus, we have 3 7s, so you say 3 by 7. Then you divide by how many they are. How many are the things? 1, 2, 3, 4, 5, 6. They told you 6 students, so you divide by 6. Then you're going to find mean. This is how you do for ungrouped data. It's not a negotiation. It's a rule. So those who have ears, hear me please, because they can change something. I'll show you. The most important thing is, the moment you see the word mean, and the moment you see data being ungrouped, listed like this, then you put this one. The sum of the things divided by how many they are. I've shown you how to do it. you punch in the calculator slowly. You say 2 times 5, 2 open bracket 5 plus 6 plus 3 open bracket 7. You get a total somewhere there. Then you say divided by 6. Then you get your mean, and you'd have your value. Is this formula. Now, let's see the other 2 types of data, because I know you can do it in no time. When we now talk about these last 2, your information will be in a table. This is grouped data. Now, let's say they tell you like this. These are the ages of students in a class. Then they say age, then they say frequency. So once they put data in a table and they ask for mean, let me fix this because it seems like there's a lag. And they ask for mean. Once they put data in a table and they ask for mean, I know you're watching. Then it's group data, and this is how you go about it. Let's say they say the age, they say people who are 7 years, people who are 8 years, people who are 9 years. Okay, this is a class of standard 5 students or whatever. I don't know, standard 4. I don't know what it is. There are 2 7-year-olds, there are 15 8-year-olds, and there are 7 9-year-olds. Then they say find the mean age, an estimate of the mean age, or find the mean age of this. Well, the moment you see the word mean, look at this type of data now. This is grouped data. If we ask you to say, tell me what type of data this is, you should say it's grouped. Then we're going to ask you to say, what makes you say it's grouped data? What are you looking at? You say it's in a table. So if I have data in a table, it's grouped. But then, this is easier. Yes, it's in a table. Yes, it's grouped. But look at this. The age is given to you as values. Look at the table in the exam paper. The height is not given as values. It's in a range. This is the third type of data. It's grouped because it's in a table. And it's continuous data. Continuous data means it's not nice values. This is not like 10, then 11. No. Here it's between 1.2 and 1.5. Between 1.5 and 1.6. You see what it is? It's data that is in a range, so it's continuous. But if it's given to you as whole numbers like this, it can come. This is data that is grouped, but it's discrete. So look, what makes you know the formula to use on those things is you can recognize the type of data. For the first thing, we had ungrouped data here. Ungrouped data like this. You should recognize, this is ungrouped data. Then you use this formula. Then you should recognize this is grouped data and it's discrete. So here's the formula you use. Sum of fx over the sum of f. Sum of fx over the sum of f. Which means that you must have a column called f times x, which you make with your pencil. You make a column called f times x with your pencil. 7 times 2, 8 times 15. Or you don't even need to. You can just do it in here to say sum of x. So you're going to say 7 times 2 plus 8 times 15 plus 9 times 7. Okay, you multiply them. This times this plus this times this plus this times this. Divided by the total frequency. Total of frequency is always the one that divides. So it's 2 plus 15 plus 7. Then now you can be able to find your things. Okay? You can punch this in the calculator right away. 7 times 2, if you want to be putting it as a times, it's still fine. So you open bracket, do the things at the top, punch it exactly as it is. Don't change. Don't be lazy. Put the brackets. Put those brackets, please. Don't be lazy. Then do these things, get answers, see what answer you're going to get when you punch it like this in the calculator. Then the bottom, you get your thing. This is over 24. You find whatever you find at the top. Then you have your answer. Then you can find the mean. So this is how you get mean here. I don't want to see anything else. Now let's get to the last bit. Is how do you now get mean for grouped data, but it's continuous? This is the last formula. So this is the second formula. You've seen us use it. It's for this type of data. You will get, if you get this type of data, then use this formula, please. If you get this type of data where they were doing in the exam, now we are doing this exam question. Blah, 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 blah. Calculate an estimate of the mean. You see the word mean? You look at the type of data you have. You say, oh, this is grouped data because it's in a table. And it's continuous data because there are intervals. So now the very first thing you must do, you look at this. This is height h. So you should find h bar. It's like this. We said that we use the third formula, which says the mean is the sum of fx bar over the total f. But sometimes your data is not x. It will be h. So you get h bar first. So here it's telling you that you will be adding f times h bar. Just like here. We were adding here. We were adding f times x. This is sum of f times x. In other words, get f times x the first one, add it to f times x the second one, add it to f times x the third one. That's what it means. This is sum. You will add after doing this f times x. So you get f times x the first one. You add to f times x the second one. You add, because this is sum, to f times x the third one. So you first do f times x. In here, it's f times x bar, but here it's h because we are dealing with height. So it's f times h bar. So we need the h bar. Why are you saying that? Why do we have this formula? Because we don't have a value here between 1.2 and 1.5 to multiply with 12. So we need to first find that value. That will be multiplying 12 times something plus 20 times something plus 34 times something plus 14 times something. Then we divide by total. That's what we want to do. So we need to find that value first, that h bar. How do you find it? You say 1.2 plus 1.5, you get an answer. Then you say divided by 2. So that's how you should get h bar. You say this plus this, you get an answer. Then you say divided by 2. Then you say this plus this, you get an answer, you say divided by 2. Then you say this plus this, you get an answer, you say divided by 2. Then you say this plus this, you get an answer, you say divided by 2. Are we together? So can you do it for me, please? What's 1.2 plus 1.5? What do you get? Say divided by 2. Say 2.7 divided by 2. You add first and get an answer, then you divide. Divide by 2, what do you get? Hello, students? Exactly. You should get 1. Now you go for the next one. Add them. 1.5 plus 1.6. What do you get? 3.1. Say divided by 2. 1.55. Don't be lazy. Add first and say equal to. Get an answer. Then say divided by 2. That's a midpoint. Don't forget, you are going to need to know how to find h bar. So you should know this formula. It's a very popular one, this one. Then you should know how to find it. Find h bar first by adding. So say 1.6 plus 1.7. Get me an answer. Then divide by 2. Yes, it's 1.65. Well done. Then what is 1.7 plus 1.9? Get me an answer first. Then divide it by 2. Yes, it's 1.8. So now look at what we do. We have found it. Now you said it's FH bar divided by H. Yes, because it's the type of data which made you say this. Because it's continuous. So now we would say, what is, we now will be adding 12 times 1.35, because that's what the formula says, you add, plus 20 times 1.55, plus 34 times 1.65, plus 14 times 1.8 divided by the total of frequency. Always add the total frequency. They would have told you here that there are 80 students, so it's 80. Okay, or 80 sunflowers, so it's 80 sunflowers. So now, get me an answer. You get the one on the top first. Don't be lazy. Punch it exactly like it is. Put those brackets. Punch it exactly like it is. Then you get an answer. Then you divide by 80. What do you get? What do you get, everybody? $128.5. Thank you. Okay? Are you seeing the main question? Method number 2. There was no bar. We didn't have to find the x bar. We just were saying f times x because we could multiply. So we multiplied them in brackets like this. You see? Then we divided by the total. Do you see it? Can you get this answer for me here? Okay, great. Good. What is the answer for this? In brackets. Do the brackets, please. Punch it exactly like it is on the top there. Okay, it's fine. You get an answer, then whatever it is. So we've done this question. If you get it, I trust you'll be able to solve it for me. All right, let me go back to documents. Let's move. I think you now know how to do it. Give me a sec. What is this? No. Give me a second. Right, look at this one. All right. This question wants interquartile range, but that's another thing. First of all, I want us to, we are not going to find interquartile range. Let's ignore. I just want us to see how we can find these missing values. Because anything we need to find that missing value called x. So, we have this data, and they said the mean of these scores is 8. Sir, how do I work with this? This question teaches my students, all of you, the most important thing about being a mathematician. A mathematician is a person who converts statements into formulas. So you are going to see the word mean, and you see that they've given you the mean, and you see the type of data. So make a formula. Don't keep it as a word. This is ungrouped data here. This is ungrouped data. So we know that mean for ungrouped data is equal to the sum of the terms divided by how many they are. We use the very first formula, which is going to be equal to, let's do the sum. we see how many 9s do we have? 1, 2. We can start with the smallest number, which is the 7s. So we have 7s. How many 7s do we have? You have 1 here, then you have 2 here. So it's 2 by 7, okay? Then you can erase. Then how many 8s? We have 1 8 here. Then that's the only one. So it's going to be plus 8. Then plus, how many 9s do we have? We say we have 1 9 here, the second one here, the third one here, the fourth one here. So plus 4 9s. Plus, how many 10s do we have? 1 10 here. Then you go up, up, up. You see another, no, nothing. Plus, how many x's do we have? We have an x here and another x. So we have 2 x's. Yes, yes, yes. Uratile. Okay. Oh, sorry for that. Okay. Okay. Yes. Okay, the second one, or the second step on here, on this. Okay. Okay, the second step, all right. So this formula says sum. So this is a sum. Everybody, when you say this is you see this is ungrouped data. So what is important is as a unit, we are learning something important here. That when you are dealing with the word mean, you look at the type of data and you must match it with the formula. Each type of data has its own formula. You must know you must know those 3 formulas, and you must know which one to use where. And you must know how to use it. This is why these things, when you learn them at school, they take time. Because your teacher wants to teach you the types of data, and maybe they won't be able to finish in the same lesson, then they say goodbye, then they teach you mean for only one type of data. But we don't have that time, so we have to move a bit fast. So I have to push a lot of information into you, which we can. It's doable. So what I want you to then do is put the rule in you, because we are not coming back. We have a lot of, we have other things to do that we are going to be doing after this. So I have to move slowly and make sure you know all the steps. And I like it because she asked me, repeat the second step. She wants to master it. When you get this question, it says mean. You see the word mean? Once you see the word mean, look at the type of data. Don't worry about the answer they've given you. We'll put the answer in the formula after we have done what needs to be done. So let's put the formula how it works, because we've seen the word mean. Let's convert it to a formula. That's success there. If you're able to do that, you're going on the right track. So you'd say, what type of data do I have? It's ungrouped. There's only one formula for ungrouped data if it's mean. You add the things, then you divide by how many they are. That's what it says. It says add all the things, then divide by how many they are. So let's add the things. When we're adding, remember to look at how many of those you have. We have a 7 here and another 7, so we have 2 7s. So you say 2 of 7s. Plus, because we are adding, this is sum. We look at the 8s. How many 8s do we have? We only have 1. So plus 8. Plus the next number is 9. How many 9s do we have? 1, 2, 3, 4. So plus 4 9s. Plus, we go again. What's the next one? 10. How many 10s do we have? We only have 1. So plus 10. Are we done? No. We are not done. We have a missing guy. Okay, let's put him in the formula. Don't worry about finding him. He will find himself as long as we stay true to the methods for each and everything. This is the only way for mean. So we are not going to change it simply because they gave us 2 x's. That doesn't change anything. Put those 2 x's in the formula. You will find them. So you're going to say plus 2 x's. Divided by the total number of things. What is the total number of things? 10. It's 10. And it is equal to the mean. What is the mean? You are given the mean. 8. So instead of mean, you can put 8. Now you can play around until you get the 2x's. That's how you do it. Yes. I see the hand is up. Yes. Ask me the question. Yes, Amanda? Okay, we'll go there. Don't worry. We'll go there, Misha. Don't worry. Amanda, you had a question as well. You can't see the screen. Let me send you a link. If you cannot see, you can use this one. You can watch. For this lesson, I've gone live on Facebook. Let me see if I can send it. Give me 1 sec. Let me forward it to you. Wait. Check this link I've put. Okay. Right. Can you see? Can you still see my screen? Everybody else, can you hear me? And can you see my screen? Amanda, did you see the link I sent you? Amanda? Okay, no problem. So, look at this now. Look at this. So what we'll be saying is, use this formula. Don't worry about anything. Use this. Convince your mind. That's the most important thing. Just tell your mind, hey man, there are 3 ways to find mean, okay? You're going to use one. There's this one. Mean is going to sum of x over the total number of things. You add, you divide by how many there are. Then the second one is mean is going to be equal to sum of fx over the total number of things. That is if you have the x to just multiply by frequency in your table. But if your table is in a range, it's continuous, then you say mean is equal to the summation of f times x bar over the total f. So you should know, it should know these 3 ways. Convince your mind. Tell it 1, 2, 3. You're going to use one of these. Done. So in here you would get this information. You see it's ungrouped. So you say, hey man, it can only be the first one. There's nothing else. There's nothing else. So you then find you put this, you say mean, blah, blah, blah. Now you can find the missing thing, the x. Because you put the formula, you had seen the word mean and 8. Obviously, it means they want you to use that formula for mean. So you put it down, then you put all the terms, blah, 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 and stuff. Now let's just combine and let's find the missing thing. So we could say 8 will be equal to 2 by 7. Can you please add all of these and tell me what you get? Ignore the x, ignore the x. Can you add this remainder here? Add with their brackets, everything which I've highlighted in green. Put it exactly as it is. 2 open bracket 7 plus 8 plus 4 open bracket 9 close bracket plus 10. Tell me what you get. What do you get? 58 or 68? 68 plus 2x all over 10. Then you take 10 to the other side. it becomes 8 times 10 is equal to 68 plus 2x. This is now something just like subject of the formula. Now you can continue here. 8 times 10 is 80 is equal to 68 plus 2x. You take 68 to the other side. Look at how it is. You keep 68 where he is. He's on the right. Stay there. You take this one to the other side. You have now 80 minus 68 is equal to 2x. If you have problems at this stage of subject of the formula, you tell me. I'll give you the videos. I explained it nicely, that one. So 12 is equal to 2x. Then you take 2 to the other side. 12 over 2 is equal to x. 6 is equal to x. So here it is. The mean is 6. Then we can continue. But the first thing I want you to do, we are focusing on mean in this question. On doing mean things. So here we have x. Now we can find anything else. Okay. I'll talk more about it, or about interquartile range and how you need to organize things, but I wanted to do the mean question. So is everybody fine on the mean question? Okay, let me put it as well to say, what you can do is like this. You can, instead of saying, I don't want to do it. Let's talk about it tomorrow because it changes the whole lesson, okay? I don't want to, I'll explain to you. I just want to focus on the things that I want to give you an assignment on, because there are lots and I haven't done them. Let's do the next thing. I'll do it. I'll talk to you about it. Just keep it there. Don't worry. We're going to cover it. I want to look at where is it? The question before this one. Right. Here is the next thing we're looking at, which you're getting questions on as well, that I want you to do and submit to me. There's the next idea. It is about variation. So can everybody forget about mean? Put the formula somewhere safe. I've recorded it. Let's talk about variation for now. Are you ready? Let's talk about variation. Variation, we have direct and inverse. So let me just explain and tell people the most important thing. Mute the mics, mute your mics, mute your mics. Mute your mics, everybody. So when we are dealing with variation, listen, there's variation and there's correlation. Those are different things. Let me talk about variation, and the most important thing that a lot of people may ignore, which can come back to haunt you. When you're dealing with variation, you are going to be told there's a line somewhere, or they can already give you it. This one is even easier because they gave us. Let's see here. When x is increased by a factor of 4, the value of y changes by a factor of something. We're coming back here. So let's say for variation, you have two quantities, maybe x and y. So they are going to say something, okay, about how these two are related. X varies as y. They can say that. Or x is proportional to y. Or to y squared, or to root y, or to whatever. Okay? X is directly proportional to y. These are three ways to say what we call direct variation. So if we have the secret about this one is this. There are two things that you just need to do here. If you do them well, then you're fine. So there's the first relationship which you must use. That one, you just use it to find the constant. Here is what happens with variation. Class, we have two types of variation: direct and indirect, or inverse. Direct and inverse variation. If you are told x varies as y, or x varies as y squared, this is all direct variation. What you do, you convert this sentence into an equation. And here's how it first goes like this: x varies as y squared. You put a fish facing the left side. This is varies. X varies, then here, as y squared, or is directly proportional to y squared. This is how you put it. Yes. You can't see my screen. Is it only you? Antonisha, can you see my screen? Mazi? Did you see I sent the link for YouTube in the group? I'm also live on YouTube, okay? And Facebook. Let me send the YouTube one. Oh, okay, good. That's better, because I want to be able to hear you guys. So Google Meet is the best. Right. So let's continue. Here is the most important. Listen, class, let's finish this one. We are finishing it. You do these stages. I know you can. I said, first is the statement: x varies as y squared. So let me practice with you also how to do the statement for inverse variation. Inverse variation, they'll say x varies inversely as, they can say as anything, as y squared, or as varies inversely as y squared, or you can say x varies inversely as whatever, we don't care. So here we have x varies inversely, or x is inversely proportional to y. These statements communicate inverse variation. And so when you read them, what should you do? You must convert that sentence to an equation. First, you convert to a relationship. You say x varies, or x is inversely proportional. Here's how you do it. You say x varies inversely as y squared. It means x is proportional to 1 over y squared. Class, if you're inversely proportional to something, it means you are proportional to 1 over that something. If x is inversely proportional to root y, then it means x is proportional to 1 over root y. Hey, do this please. Inverse proportion means you are proportional to 1 over that something. If x is inversely proportional to b squared, it means x is proportional to 1 over b squared. But if it's directly proportional to b squared, it means x is proportional to b squared itself. Do you see? Students, can you see this? So indirect proportion is just you are proportional to 1 over that something. That's inverse. That's the inverse relationship, or the inverse variation. That's what it is. Proportional to 1 over something. So throw away what your mind thought and take this, and let's move on. 1 over something. So let's put y squared so that we have consistency. So it'll be proportional to 1 over y squared. So first of all, everybody in the class should be good at this first stage. This fish, which faces the left. Are you all good at it? For direct variation, you just put it like this. Then for inverse, you say it's proportional to 1 over. Then the next step is to change this relationship to an equation. It's easy. When you change this relationship to an equation, you just multiply the right by k. So that's second step. So it will be here, it will be x is equal to some constant k multiplying y squared. In here, again, it will be x is equal to, you now put equal to, you remove the fish. It will be k over y squared, because you have also multiplied by k on the right. So it will be k over y squared. Here it will be ky squared. Can you see this? Can people see this? Are we on the same page? Students? Antonisha? Okay, which stage? All right, let me repeat it again. Let me say this. There are two things involved. This, we are going somewhere. I want you to see. Okay, there are three things that you must know how to do if you want to solve questions to do with this. The first thing that everybody must know how to do is, if they give you as sentences, you must be able to change sentences to a relationship. That's the first step. Everybody in here should say, that one I'm good. That one I'm good. On direct variation, if they say x varies as y squared, or x is directly proportional to y squared, or x is proportional to y squared, that's direct variation. So your first step will be x is proportional to y squared. Done. That's what it is. They didn't say inverse. There's nothing which says inverse. So you put your fish. You should know how to do it. X is proportional to y squared, because that's the other one which they put here, the y squared. So we are having a relationship between what? Between x and y squared. So, and how are they related? They are varying the same way. So x is proportional to y squared. X is proportional to y squared. This is the very first step. Are you all able to do the first step? If they say the word inverse in variation, then you say x will be proportional to 1 over that guy they would have given you. So if they gave you x squared, you are now saying x varies as 1 over that guy. That guy happens to be y squared in our situation. So x varies as 1 over y squared. This is the first step. Are you all able to do this? Students, are you all able to convert these sentences to this relationship? Now we go to step number 2. Step number 2 is this. You are never in your whole life going to be able to solve anything with a fish that faces the left. This fish that's facing the left is good, but it's not anything. You can't solve. So you need to now remove it and put an equal sign, buddy. You need to remove it. You got to remove it and put an equal sign. And the rule is this. If you remove a fish and put an equal sign, multiply the right by a constant. We are not asking you. You are not allowed to remove the fish and put an equal sign and keep it as a what? No. Put a k multiplying the right. It could be a k or a d or an a, but there should be some new letter. We usually use k on the right. So we want to see it. Here again, it's there. And it's multiplying the fraction. When you multiply the fraction, you only multiply the top. So it goes straight to the top, the k, because it's multiplying the 1 over. So this is what it becomes. Are you seeing this? Are we on the same page? LGK, are you in the class? And have you seen this? Now, listen, everybody. the last step. Listen. Let me tell you. The last step is this. You are going to be given a relationship. That relationship is there so that you can get K. You gotta get K. Because as long as we have K, we are crippled. K should go. And we should have a number where there is K there. So you are going to be given a relationship. That relationship you are given is so that you remove K and put a number. Then you can be able to solve anything else. So once I have an equation, the next step I am going to have is to remove K. How do I remove K? They are going to give me a value of X, a value of Y. And you are going to feed these values into this equation so that you find K. Once you have K, you will rewrite this. But K should no longer be there. Will be now, let's say you find your K to be 5. We now expect to see you say X will be equal to 5 over Y. This is now what we want to see. A relationship without K. Because when you have X is equal to 5 over Y, they can now ask you to say, what is the value of X when Y is 10? Or what is the value of Y when X is 7? The only way you can get there is if you have removed K. Then you can start finding anything. Let's go to a question. Okay? Different questions. We want to do different ones. We start with this one. This is the first one on variation. Right? Here we've already been given a fish. Practice makes perfect. But the secret is, when you're practicing, stick to the rules. Don't do your Chinese stuff. So listen here. If I have a fish, what's the next step? You gotta remove the fish, right? Is it not? You have to remove the fish and put an equal sign, right? So you'd say, Y is proportional to 1 over root X. Follow the steps. The next step is, this fish is a meaningless thing. You gotta remove it and put an equal sign. So Y will be equal to 1 over root X. Class, no, I'm lying. Y will be equal to K over root X. Because you need to put a constant. If you don't put a constant, you are in trouble. Class, let me say, the most important thing about why we are doing this maths and doing it this way is we are learning steps. This is a painful process because you are removing things and you are adding things in an orderly manner. It's painful. But once you get the hang of it, you are good for life because you follow maths in steps. You can't make a mistake. This is a very, very important thing. Please, mathematicians, follow the steps. Don't be lazy. So when you remove the fish, you got to put a K. So you have the equal sign, but there's a K. Well done. You've done a good step. You've done well. But now you have another problem. The next problem is get rid of this K. Remove him. And how do you remove him? I said they are going to give you a good one. They'll give you both X and Y. Why have they done this? Because that's not the question. The question is here, but don't look at the question for now. Because you still have K, you can't solve it forget. You have to remove the k. You got to remove the k so that you can be able to solve this one. So we remove the k using these ones they give us. They gave us x, they gave us y. What is y? 2 is equal to k over, what is x? Root of x is 9. Okay, we can do it here to say y is 2, so you say 2 is equal to k over the square root of x, which is the square root of 9. You have 2 is equal to k over the square root of 9 is 3. You take 3 to the other side, you have 2 times 3 is equal to k. And you have it as 6 is equal to k. So you have found k as 6. You come back and you put it there. You don't want it there. So you now say y is equal to 6 over root x. Hooray! Well done. Now you can look at the question. Don't look at the question until you get to this stage here. Are we together? Now you can look at the question. What does the question then say? Find the value of y when x is 36. So you come here and you say, let x be equal to 36. So you now have y is now equal to 6 over root of 36. Which you now say y is equal to 6 over root of 36 is also 6. You get y equal to 1. So the value here is 1. Hey, I don't want to hear anyone telling me from this class, I'm not good at maths. What are you talking about? What are you talking about? What are you talking about? Follow the steps. I don't care who you are. If you follow the steps, you are 100% student. There's nothing called knowing maths where you are born knowing maths. There's nothing like that. We have to learn. So I don't want to hear that. Let's look at here. When x is increased by a factor of 4. Factor means you are multiplying. So if I'm increasing x by a factor of 4, it means it's a 4x. Y changes by a factor of p. It means 4x is proportional to py. Kind of like that. When x changes by 4, y changes by py. Stuff like that. Even if you put it as an equal sign, 4x is equal to py. No. 4x is proportional to py. So, oh, it's related to this. Okay, sorry. It's a part B, so it's related to the first one. Let's write the relationship between x and y. Y is equal to 6 over root x. So now they're saying x increases by a factor of 4, so it's going to be y increases by a factor of p. So py will be equal to 6 over root x. So 6 over root of 4x. Stuff like that. Can you see it like this? Then you can be able to solve and find. They said find the value of p. P will be equal to 6 over root 4x divided by y. I guess something like this. I'll confirm. This one has caught me. Huh? I'm not a gimmick. Gimmick means a person who has all the answers. I'll put a star on this one to find out what they wanted us to do. Let me go to a different one and use the same concepts. This is sequences. Before sequence, we want to do another one on, let me see which one it is. We want to do another one on directed inverse variation. So, summer 25, question paper 43 should be the other one. Yeah, it is. Wait. not this. It's not this question, but give me a second. Excuse me. There should be another one close by. Okay, let me give me a minute to load it. Somebody needs to mute the mic. I just want to do this, even if you do it as the last one. Let me put it in the group. The question I want to do, maybe this one and this one. Wait. Sorry. Right. Let's do this. I think by now you know I am big on steps. Look, the answer is something. Yes, Gift, I see your hand is up. Gift, do you have a question? You can say 2 into 2, 1, 2 into 6, 3. We could say 2 into 2, 1, 2 into 6, 3, and get it like this. Then, but what makes me not do that is the question had 1 mark. So I want to find out what Cambridge want. Where is the theory? That's a good one. That's well tried. But what made me not do that was the question has 1 mark. So I just want to find out more. Yes, it should be something simple. It should be a concept that we should use to answer that one. All right, let's finish it here. Let's do this one here. It says m is inversely proportional to the square root of t plus 2. I am big on the steps. I said step number 1 is you read the sentence and you convert it to a relationship. Read this, convert to a m is inversely proportional to the square root of this. So m is proportional to 1 over. That's the inversely proportional. You say m, then you put your fish facing the left to 1 over. That's inversely proportional. It's 1 over. Then here they say square root of t plus 2. So the root of t plus 2. Okay? Nothing catches here. We are fine so far, right? Now let's follow the steps. Don't you read this question. Don't read that question. Next step is remove the fish, put an equal sign. How do you remove fish and put an equal sign? You multiply the right hand side by k. So you say m is equal to k. When you multiply the right hand side, it just goes on the top. So it's going to be k over square root of t plus 2. Then now, what do? You've done well. What do? You have to eliminate k. Eliminate him. It's a problem. You use this. The one you would be given. M is 0.5, so you can say here, let m be equal to 0.5. And t is 23. T be 23. So that means where there is m, we put 0.5. So you now say 0.5 is equal to k over square root of, where there is t, you put 23. So it will be 23 plus 2. Because it was t plus 2. So you now say 0.5 is equal to k over the square root of 23 plus 2 is 25. So what is the square root of 25? It's 5. So 0.5 is equal to k over 5. What do we then do? We then put it like this. We say 0.5 times 5 is equal to k. Okay, because you take 5 to the other side, multiplies. What's 0.5 times 5? Because you take 5 to the other side, it will go and multiply there. What's 0.5 times 5? It's what? 2.5. This is k. Are we done? No. You have removed k. Well done. You come and you remove him here. So you will now say m is equal to, the only thing we hate is k. 2.5 divided by the square root of t plus 2. 2.5 divided by the square root of t plus 2. Then now we can answer all questions. We have the weaponry. We have the things we need. So now they said find m when t is 98. So you're now coming below. You say let t be equal to 98. M will be equal to 2.5 over the square root of 98 plus 2. How easy? Which is 2.5 over the square root of 100. What is m? Square root of 100 is 10, okay? You put it 2.5 over 10. What do you get? M is 0.25. Surely you are not going to let 3 marks go. This easy 3 marks. Come on now. Do we have a question? Do we have a question, class? Class, do we have a question? Okay. since we've already gone strongly in maths, let's just do one more thing. One more concept, which is an interesting one. Do you think you have space to do one more thing? Do you, or should we? Those who say we do one more concept in maths, or those who say it's okay for maths? Let's do a vote, because I want to see if I should do one more. I have those things that I showed you that I wanted to give you as assignments, small things in each thing. So far I'm giving you mean. I'm giving you this for M, and I want to open one question on nth term, just to revise with you on what I told you, and on similarity, just to revise with you on what I told you. And then I think those will be enough, right? We'll do other things going forward, okay? We shouldn't try to finish everything in one day, but it's good for us to cover a lot of ground. It will create space. So we'll also do bounds, and we'll also do graphs and whatever. We'll do them tomorrow. Anyway, let me think. Should I continue? Should I? Okay, we can stop maths here. Those who want to do the things we did yesterday, go back and watch the videos from yesterday on nth term and on similarity and congruence. Then you'll be able to answer the questions. Maybe should I answer the question, or we can change subjects? What do you say? Should I answer a question on similarity and congruence and on nth term? Those who say I should answer, raise your hands. Is that all? Those who say I should answer a question on nth term and on similarity and congruence, raise your hands. Okay, it's 12. I'm gonna lower all hands. It's 12 people. Okay, I've lowered all hands. Those who say let's change, oh, Lehakwa makes it 13. Those who say we change to something else, raise your hands now. If you say we change, it's enough. You can use what we did already. Oh, only 3 people. 4 people. So we are answering the questions. Okay? I'm going to answer the questions. I'm going to do a question on nth term from a past paper, then on similarity and congruence. So you can do the assignment. This is on the graph we'll do tomorrow. All right, here is one on similarity and congruence. Right. Let's answer this question. You see, I'm not interested in the type of question. Like, I've never been interested in that. I'm not interested in the type of question. I'm interested in knowing the concept. So, I'm not interested in the type of question. The type of question does not change. I'm not interested in the type of question. I'm interested in the concepts. For similarity and congruence, class, remember, we said that we have 3 things: scale factor, area factor, and volume factors. Everybody make sure your mics are muted for everybody to be able to listen nicely. There are 3 things: scale factor, area factor, volume factor. Now, what you must remember is that these 3 are always going to be multiplying the OG. So when you come to a question and you see the word similar, right? The first thing you do is you choose which shape is going to be the original one, then which shape will be the new one. The new one should be the one without info. The one without information should be the new one, which is missing something. So H is here, so it's the new one. That's the first thing. The second thing will be, you have these three words. Number one, you must know how to come from one to another, yeah? And then number two, you must know how to come from shape to another using these words. We know that if we are dealing with lengths, we say OG length, okay? Or we can say length 1, whatever you want to say. Length 1 times scale factor gives you the length on the second shape. So you can call it length 2, length on the new shape. So this will be shape number 1, shape number 2. You can still do that. Instead of OG and U, maybe 1 and 2 makes it faster. 1 times scale factor gives you 2. So length 1 times scale factor gives you length 2. The most important thing that everybody should see here. Oh, sorry. Let me fix something. Okay. Let me fix this graphics. The most important thing that I want everybody to see is that, sorry, I'm fixing graphics, is that scale factor multiplies lengths, okay? Is that scale factor multiplies lengths. So now if you say area 1 times area factor, you get area 2. Area factor multiplies areas. Area 2 is area on shape number 2. Then volume 1 times volume factor gives us volume 2, or the new volume. Right, that's what I want everybody to know. Then the last thing which you must know is that scale factor squared gives you area factor, and scale factor cubed gives you volume factor. With this you have enough information and you can answer any question. So put the 5 things. 1, 2, 3, 4, 5. These are the 5 things that we need. These are the 5 things that we use to answer this thing. Now we go to question time. Right, let's go to question time. We says here, the height of a solid is blah 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 blah, and its surface area is blah 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 blah. The surface area of solid B is blah 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 blah. So here is the thing. What is it that we have for the first one and for the second one? They are calling it solid A here. We have solid A and we have solid B. So here we can, instead of using 1 and 2, we can actually use A and B. We can say length of A times scale factor gives you length of B. Make it red. And we can say area of A times area factor gives you area of B. If you are working with areas, you need area factor. Volume of A times volume factor gives you volume of B. So you must know that. All right. So now they've said calculate the height. Don't worry about the question. Don't worry about the question. We see the word similar. Okay, thank you. What we then come to do is we see what have we been given. What have we been given, class? We've been told that area of A, okay, we only want something that we know for both A and for both B, for both A and B. Here we've been told surface area for A and surface area for B. So we have area, right, for A and for B. So we are going to use this formula. Write it. You're going to say area of A times the area factor gives you area of B. Don't change. Don't get in there and change your method. You affect everything. Area of A times area factor gives you area of B. What is the area of A? What is the area of A? A is area 60. So 60 times area factor, we don't know it, is equal to area of, why are we doing this? Because we saw the word similar. Area of B, what is it? 540 centimeters squared. Here you can put, this is 60 centimeters squared. Now let's find area factor, class. Area factor is equal to 540 centimeters squared divided by 60 centimeters squared. What is area factor? 9. So area factor is 9. Now they want the height of something, which is a length. The only way you can get lengths is if you know the scale factor. So we have area factor, we want scale factor. We know the relationship says this. Scale factor squared is equal to area factor. So we want the scale factor, so we are going to take this squared to the other side. We'll say scale factor will be equal to square root of area factor. That means scale factor is equal to the square root of 9. Scale factor is equal to 3. So the scale factor is 3. Thank you for finding it. But is that the answer? No. We now say height of A times the scale factor should give you height of B. Because it's a length. It's a length of A times scale factor gives you length B. So yeah, height is a length. What is the height of A? 7 centimeters. Times what's the scale factor? 3 should give you the height of B. What's 7 times 3? 21 centimeters is the height of B. So you found it to be 21. And you're done. Look at how neat it is. Look at how easy it is. Look at how the answer has come so easily. Why? Do you know why? It's because steps are being followed here, ladies and gentlemen. This is not haphazard. There are procedures, and no matter what, you don't break them. You only use the things on the screen. Nothing from your own head that is not a formula, because it will cost you. Are we together? Hello, people? Okay. Let me do one more. Summer 25, question paper 40, I guess. Can you see this? I think a lot of you already have ideas because you are going to follow steps. So what you see the question and you see the word similar. You smile. You know that if you follow steps, you'll be fine. So you are not scared of anything there. Now here they say triangle ABC blah 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 are similar. Thank you for your information. So let's call this shape A. Let's call this shape B. We saw it from the last question that it works. Calculate length PR. Of course, they'll never say what to use. Let's do it in steps. Then we can get to. We see the word similar, right? We write the 5 important things that we must know. So length, okay, length of shape A times the scale factor should give me length of shape B. Okay, we'll call this our shape A and this is our shape B. Area, whether it's surface area or what area of A, times area factor gives me area of B. Volume of A times the volume factor gives me volume of B. Scale factor squared gives me area factor. Scale factor cubed gives me volume factor. This information can take me through this chapter if I use it well. Yes, it can, if you use it well. Let's see if we can. Let's see if we're going to do that. Calculate length PR. It's a length, so it has to do with scale factor. Do you have the scale factor? No. Find it. So, what do we know? I can choose a side that I know on both shapes. This side, I know it on both shapes. It's 9 here, it's 6 here. So I'm going to say length on A times the scale factor gives me length, the same length on B. You can even do it better. What is the length of A? It's AB times the scale factor should give you, what is the length on B? PQ. So let's do it. What is AB? 9 centimeters times the scale factor should give you 6 centimeters. Then you take 9 to the other side. You now have scale factor is equal to 6 centimeters divided by 9 centimeters. Of course, the units should always cancel. It should have no units. Scale factor, volume factor, area factor, no units. Centimeter and centimeter cancel. 6 over 9 is like 3 into 6, 2. 3 into 9, 3. So it's like 2 over 3. Now, that's the same thing you use to find PR. Because you say, what is the length here? It's AC. So you're going to say AC times the scale factor should give you the length on PR, which is PR. What is AC? 12 times what's the scale factor? 2 over 3 should give you PR. Let's get the answer. You say 12 times 2, then divided by 3. That's 24 over 3 is equal to PR. 8 is equal to PR. So you can put your 8 centimeters and you're done. Can you see this? Because we picked the length on A, which is AC. We multiply by scale factor, we should get the length on B, which is PR. Then we come here. Triangle, blah, 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 are cross sections of 2 prisms. These prisms are similar. The volume, what? So you've been given volume of 1. Volume of the smaller prism, which is the volume of A. Because is A the smaller one? Which one is the? No, it's B. So you've been given the volume of B. It's this. Now find the volume of the larger prism, which just means find volume of A. Is this about volume? No, it's not about volume. So what is it about? It's about you finding the volume factor. You're going to say scale factor cubed is equal to the volume factor. What is your scale factor? 2 over 3. So you say 2 over 3 all cubed is equal to the volume factor. What is 2 cubed? It's 8 over 3 cubed is 27. This gives the volume factor. Why are you finding volume factor? Have you lost your senses? Are you just finding volume? No. I saw we are now dealing with volumes. Similarity on volumes. So we need volume factor. Now what will we say? We will say volume. We now use the formulas. Since we now have volume factor, we now use the formulas. Volume of A times volume factor gives us the volume of B. Volume of B is the smaller one. You got it as 1. So what is the volume of A? You don't know. You call it V. Volume factor 8 over 27 should give us the volume of B. What is the volume of B? 1120. So to then get the volume, you say 1120. You take the fraction to the other side, it will spin, times 27 divided by 8. Can somebody get what's the answer there? What is 1120 times 27, then divided by 8? What do you get as the answer? Okay. Thank you for your attention to this man. You get your marks. Last thing. Well done. You go back and watch this video if you need to. Last thing, class, which we said we do before I give you the assignment, is questions on nth term. So let me load them. March 25 question paper 4-2. Complete the table to show and look at the marks. Wow, this is a lot. Imagine. To show the nth term of each sequence. All right, no problem. We start with sequence number 1. 5, 12, 31, 68, 129. Let's find the nth term here. We said first thing you do is the differences. What's 12 minus 5? 7. 31 minus this. Can you find me, please? 31 minus 12. 19. 68 minus 31. 37. 129 minus 68. 61. So the difference is not yet the same. So we now go for the second difference. 19 minus 7. 12. You say 12? 37 minus 19. 18. 61 minus this. 24. Now, what is 18 minus 12? 6. 28 minus 18? 6. So, already we can see that the difference became the same on the third thing. So, it starts as an n cubed. It's a cubic sequence, which we didn't really talk about. We need to talk about it clearly. You can see that it comes. Because it only becomes the same on the third difference. Can you see this? That it only becomes the same on the third thing. Can you see? Class, hello? So, because it becomes the same on the third, that means it's an n cubed. It's a cubic sequence, okay? That is the most important thing. It's a cubic sequence. Now we will need to find the other parts. We didn't really talk about cubic sequence yesterday, which we said it gets all the way up to here. So let me put it like, we'll do the working for this cubic sequence here. This is a cubic sequence. And we need to find this nth term. So what is the first thing? We've seen that the difference becomes the same on the third. So you should say n cubed. Don't forget. Okay? I'll do the other parts. I'll do the other parts. Let's try to start with the other ones that we already did. Let's start with the other parts that we already did. What do I do when it's 10 over 3, 9 over 4, 8 over 5, 7 over 6, and 6 over 7? I want to see what type of a sequence is this. We start with the easier ones. Can you subtract this? Somebody say open bracket 9, then you press the button which says A, B over C, and you say 4, you close, you say minus, then you say open bracket, you say 10, then you press the button which says A, B over C, it means over, then you say 3, then you close. What is 9 over 4 minus 10 over 3? What is the answer? Put brackets, don't ever leave those brackets. Come on, I always say that. What is it? What is it, class? Hello? Give it to me as a fraction. If you want to put it as a fraction, press the button, second F, then A, B over C. Do you get it as a fraction now? Okay. Negative 13 over 12. Let's see for the second one if it's going to be the same. Can you do 8 over 5? Okay. You now know how to do it. It's 8, then you press A, B over C, then you say 5. Minus, you now say 9, then over 4. What do you get? Remember to say second function. Negative 13 over 20. Okay. Then do for the next one. For here, say 7 over 6 minus 8 over 5. It's not about the hardness of the question. It's about the stages, okay? The questions, some of them are different. You know, their level of difficulty is different. But the concept does not change. What is it? Negative 13 over 30. Okay, then let's do the other one. Let's say this one now. So I did this minus this, this minus this, this minus this. Now say 6 over 7 minus 7 over 6. Okay. Right. Now let's subtract them. The difference, we can clearly see that it's not the same. Let's subtract them here. Let's say this minus this. We keep going until we start getting the same answer. We just do that until we get the same answer. Where is it hard? So I want you to open bracket and say negative 13 over 20. Then say minus, then put this. You say open bracket, negative 13 over 12 is equal to, what do you get? You get 13 over 30. Do it again on here. Open bracket, negative 13, AB over C, okay? Open bracket, negative 13, then you say AB over C, 30, means over 30, minus, open bracket, negative 13, AB over C, 20. What do you get? Hello? Students, Lekako, what do you get there? (13/60). I agree with you. Then now do this last one. Do this last one. Open bracket, negative 13/42. Okay? Then you say minus, you open another bracket, you say negative 13/30. What do you get? You do the one in front minus the one behind. What do you get? Hello? Why are you quiet? Do you agree? You got 13/105. Subtract them, let's see now. And see if you get. You see the difference is still not the same. You subtract again. So these are all cubic sequences. Let's confirm if the last one is also cubic. That's why this had a lot of marks, right? 4, 8, 16, 32, 64. What is the difference between these? 8 and 4. The difference is 4. Well, this one actually, you didn't really have to calculate. Okay, I'll do a game, something. I'll show you. If we say 8 minus 4, you get 4. 16 minus 8, you get 8. 32 minus 16, you get 16. 64 minus 32, you get 32. Now, you can see 8 minus, this is changing. 8 minus 4 is 4. Okay? 16, sorry. What am I doing? 8 minus 4 is 4. 16 minus 8 is 8. 32 minus 16 is 16. 64 minus 32 is 32. Yes. 8 minus 4 is 4 here. 16 minus 8 is 8. 32 minus 16 is 16. 8 minus 4 again 4. 16 minus 8 is 8. Wow. 8 minus 4 is 4. Okay, so here there's a I think here there is a way of analyzing, because what I can see is that we can see what the sequences are doing. For here, you can see that you go down one step here and you go up one step here. You go down one step here and you go up once. We just need to change that to an nth term calculation. Okay, we can change it. I'll try and do cubic sequences with you tomorrow. I actually was not aware that they come for IG, so this is very important. I'll try and do cubic sequences for you tomorrow and see what the answers would be for this table which they've given us. But let me do the second one, which I had put for you, which is a little bit easier, which is a paper 2 question. It's a May-June 2025 question paper 2-2. So it's summer 25 question paper 2-2. It's this one. No, this is the graph part. I want the here. No. I want question paper 2-2. It's the last question. Let me put it to you. It's a much easier one. Let me put it to you in the group. Tomorrow we'll finish with maths if we do it. We'll start with the other subjects. Um, all right, can you see this? Students, last question. Hard work, hard work. Thank you. Let me put it like this. Here's an M term. These are the ones I'll give you for the assignment. I won't give you that table. I'll solve it myself after the lesson. 11 minus 8. So here, let's find the difference, okay? Okay, first question says find the next term of this sequence. All right, let's find it. Here, 11 minus 8. You can see that. What is 8 minus 11? If you want to find the difference, you say the one ahead minus the one behind. You say you get negative 3. 5 minus 8, you get negative 3. 2 minus 5, you get negative 3. So you're seeing that it's going down by 3. So you say 2 minus 3, you get negative 1. So the next term will be 2 minus 3, you get negative 1. Negative 1. Okay, so next term is negative 1, so that it's a negative 3. Nth term of this sequence, since it's a negative 3, you already start it as negative 3n. Okay, because it's a linear sequence, you can all see that this is a linear sequence because it is having the same difference of terms. Now, what is the last thing you do? The last thing you do to find what you add here or what you put here. So it's like you say Tn is equal to negative 3n plus some value x, like we were doing yesterday. You put some x here. Then to find this x, you now say x will be equal to, you say the first term, 11, minus this difference. So minus negative 3, which is 11 plus 3, which is going to be 14. So you already know that you can say this is 14. So Tn will be equal to negative 3n plus 14. Or you can say Tn is equal to 14 minus 3n. That's better because the 3n is the one which is negative. So you can put it at the back. So it'll be 14 minus 3n. Are we together? This is the one I'm going to give you to do, okay? Which is a little bit on the easier side. Okay? So, big questions coming on all the things we've done. I'll do those questions and I'll explain to you tomorrow. As the last thing. First thing is the other 3 subjects, then we'll do this as the last thing. Okay? Let me just take your attendance. You really soldiered on. Well done. I'll fix accounts for those that need accounts so that you can check the videos I recorded. In September, we'll be doing streams where we do the whole paper for all subjects. So by then we should be done studying, we should be doing the whole paper together. Okay? We do a lot of papers from like 2018 all the way to 2025. That's for September. All right, attendance complete. Remember one thing, to get this part, remember you say first term here minus common difference, which is you put it in here. So then you get your thing. Remember to do it. Get me 90s and 100s, please. I'll give you the work. Let's see how you guys perform. It's gonna start coming in the next few minutes. You see the work. Thank you, everybody. Goodbye. No maths tomorrow. Oh, we'll do it last. I just wanted to do these things. We'll do it last. We'll still continue with these hard things from papers. But tomorrow we start with solving the Punnett squares from past papers for bio. These ones, let me show you. I've already gathered them. I thought I was gonna get time to do all the things, but time is a different creature. It's still fine, don't worry. Biology. So, Punnett square questions are these. These are all Punnett square questions. Let me share screen so that you can see. Let me share it as the screen, not as a tab. Look at this. Right, look. From here all the way to the bottom, these are all Punnett square questions that I was supposed to do. So here, no, not this. Look at this. Punnett square. Can you see the Punnett square? With these genotypes and whatever. Look at this again. This is now a pedigree diagram, which is fine. We'll still do it. Plus this again, which is like a Punnett square, same thing. Here again, pedigree charts. Then you do another one. These are different papers, eh? This is paper 4.1. This is paper 4.2. Paper 4.3 again. You had another Punnett square stuff. You are mixing alleles and you're trying to predict the probability of something. So we were gonna draw it. Here's another one again, which we'll do again. There we go. Here's another one. Let me just show you. Here's another one again, which we're gonna do again. Nah, this one is about variation and selection. I won't talk about it right now. I'll talk about it after we finish. If only we can finish, because I'll be having a lot of things I want to do, but time. Oh. So here is more, and plus more again. So you can see